uses random values from the available key space. To make it clear that what is the role of key space, I'm going to give you an example. Dear students, if there is an algorithm and which is using only 2 bits key, so the key space for that algorithm would be 4, and the values of these keys may be 00, 01, 10 and 11, which indicates that the total number of different keys that would be possible. As there are only 4 possible combinations which can be used as a key in the algorithm, so it would be easy for the intruder to figure out them, and it will it would not take an attacker very long time to find the correct key. A large key space allows for more possible keys. Dear students, nowadays there are so many encryption algorithms which are being based on 128, 256, 512 or even 1024 bits and larger key sizes. Let's imagine if there is an algorithm which is based on a key of size 512 bits. So it would provide 2 raised to the power 512 possible combination, and which will give us a very large number. So the key space of that algorithm would be extremely large, and it would be very difficult, or it would give a tough time for the intruder to find out the exact key which is being used during the encryption. And the encryption algorithm should use the random values for a key. So if the encryption algorithm use the entire key space and choose the values to make the keys as randomly as possible, it would be considered as impossible nowadays to find out the exact key which is being used for encryption, and the communication would be considered as safe communication between sender and receiver. Dear students, in this table you can see what would be the effect if we increase the length of key. As you can see that if there is a key of 1 bit, the possible combinations would be 2. If there are 2-bit keys, if there is a 2-bit key, it will produce 4 possible combination which can be used as an key. As we increase the number of bits, the number of possible keys would be increased. As you can see in the table, the algorithms based on a key size of more than 100 would be considered as strong encryption algorithms, because it would produce more number of combinations for a key. Link encryption. Link encryption is a series of encryptions and decryptions between a number of systems, whereas each system in a network decrypts the received message and then re-encrypts it using different keys and send it to the next neighbor, and this process continues until the message reaches to the final destination. Dear students, link encryption is being carried out in a communication when multi-hops are involved. Another term which is being used in cryptography is known as steganography. Steganography is the hiding of message, for example, within the digital encoding of a picture or graphic. Dear students, steganography is a method of hiding data in another media type, so the very existence of the data is concealed. Only the sender and receivers are supposed to be able to see the message because it is secretly hidden in a graphic file, or it may be a WAV file, or it may be a document, or it may be any other type of media. In steganography, the actual data is not encrypted, it is just hidden. The last but not the least terminology of cryptography is going to be discussed in this slide, and that is work factor. Dear students, work factor can be considered as the amount of efforts, usually in hours, required to perform cryptanalysis to decode and encrypt message when the key or algorithm or sometimes both are unknown. In short, it is an estimate of the efforts and resources it would take an attacker to penetrate a crypto system. Strength of an encryption method comes from the algorithm, the secrecy of the key, the length of the key, the initialization vector, and how they all work together within the crypto system. When strength is discussed in encryption, it refers to how hard it is to figure out the algorithm or key, whichever is not made public. The strength of encryption algorithm correlates to the amount of necessary processing power, resources, and time required to break the crypto system or to figure out the values of the key. Breaking a crypto system can be accomplished by a brute force attack, which means trying every possible key value until the resulting plain text is meaningful. Dear students, depending on the algorithm and length of the key, this can be an easy task or one that is close to impossible. Goal of designing an encryption algorithm is to make it too expensive or too time consuming to be compromised by an intruder. Services of crypto systems include confidentiality, integrity, authentication, and non-repudiation. Confidentiality refers to the information unintelligible except by authorized entities. Military and intelligence agencies are very concerned about keeping information confidential. So they would choose encryption mechanisms that provide a high degree of secrecy or confidentiality. While the integrity refers to that the data has not been altered in an unauthorized manner since it was created, transmitted, or stored. So, financial institutions care about confidentiality, but they also care about the integrity of the data being transmitted. So, the encryption mechanism they would choose may differ from the military encryption methods. If messages were accepted that had a misplaced decimal point or a zero, the ramifications could be far-reaching in the financial world. So, they would prefer to use an encryption algorithm that provide confidentiality as well as integrity. Authentication verifies the identity of the user or system that created information. The legal agency may care most about the authenticity of the message than confidentiality and integrity. If information received ever needed to be presented in a court of law, its authenticity would certainly be questioned. Therefore, the encryption method used must ensure authenticity, which confirms who sent the information. Dear students, non-repudiation ensures that the sender cannot deny sending the message, and obviously this type of service would be demand of all fields of life. So the encryption algorithm being used by any field of life must provide non-repudiations. Now I would summarize all these services by a simple example. Let's say we have a boss in a company and he sent a message to his employee in which he tells him that he will be receiving a raise of salary that would double his salary. Now, the when the message is encrypted and sent to the employee, what does it mean? It means authenticity is provided by the boss. The message is being sent by the boss. Someone did not alter it before it arrived at his computer, at the computers of employee. What is this? The service of integrity is being provided. No one else was able to read it as it traveled over the network. So confidentiality is provided. The boss cannot deny sending it later when he comes to his sense. So it means non-repudiation is provided. Dear students, this was all about cryptography definitions and concepts. If you have any question or any query, put it in the KCMS. I will try my level best to answer your queries or questions. Thank you. Have a nice day. Allah Hafiz.